Hello and welcome. In this video, we will talk few more examples on DFA. The first one is construct a DFA that accepts the set of all the strings over alphabet A comma B, which starts with A and end with B. So all the strings must start with A and they must terminate with B. So our language L would be A, B, that is the smallest possible string. In between A and B, we can have any combination of A and B. So that could be AAB, ABB, AAAB, AABB, ABAB, ABBB, and so on. Okay, we have infinite strings. Let us first design DFA for smallest length string, that is AB, and then we will adjust the arcs. Right? So this will accept strings AB. Okay, strings must start with A, so we cannot have arc of B from Q0. If we do so, we will go to the dead state, right? Because string must start with A. From Q1, arc of B is already out, arc of A needs to be adjusted. So first we'll always try for the shortest possible arc. So can we have self loop of A on Q1? And if doing so, if we are able to generate valid string, then we will keep it. Otherwise we will increase the length of arc. So yes, that is definitely possible, because if I am reading the first A from Q0, I am going to Q1. From Q1, if we are reading n number of A, and then when we read B, we are going to Q2. So this will ensure that all the strings generated through this will definitely start with A and end with B. So that is satisfying the condition. So we can keep this arc. From Q2, can we have self loop of A? That is not possible. Otherwise, string will end in A as well. Whereas condition is that string must end with B. So arc of B is possible. This will generate all valid strings which are ending in B. But when we read A, it will send us back to the Q1. Because self loop is not possible, so we have to check for the next larger arc. So from Q2 to Q1, when we read A, we are moving there, and to go to the final state, again we have to read B. So that ensures that definitely string will end in B. So this is the desired DFA. Construct a DFA that accepts the set of strings over A comma B which starts and ends with different symbols. So if string is starting with A, it should end with B, and if it is starting with B, then it should end with A. The start and end symbols should be different. In between those two symbols, there can be any combination of A and B. So if our string is starting with A, it must end with B. And if it is starting with B, then it must end with A. So this DFA will produce only two strings, AB and BA. Now we need to adjust the arc so that we can produce rest of all the strings. From Q0, both the transitions are out. From Q1, transition of B is out, transition of A is still left. Can we have A as a self loop on Q1? Obviously, we can do that, because if after reading any number of A's, we must have to read one B to go to the Q2. So that ensures that last character is definitely B, first character is A. And string is ending in B, so we can read any number of B's from final state Q2. Right? So we can have first letter A, then there is any number of A's, and then there would be any number of B's. So all string would be definitely ending in B. And when we read A, it will come back to Q1. Right? Because we cannot have a self loop of A on Q2, else string will end in A as well. So this will ensure that whatever strings we are generating through this path are starting with A and ending with B. And same arcs we have to replicate in another unit, another part. But now input symbols will be different. Instead of A, we will put B, and instead of B, we have to put A. So that will be the desired DFA. Construct a DFA that accepts set of strings over A comma B which starts and ends with the same symbol. Okay? So now epsilon would be the part of language, because epsilon is having the same start and end symbol, because there is no symbol. So no A, no B. Similarly, only string A, it is starting with A, it is ending with A. Only symbol B is also starting with B, ending with B. So they have a same start and end symbols. Right? So in general, we have to generate all such strings which are starting with A, then they must end with A, and if they are starting with B, then they must end with B. In between, there could be any combination. Epsilon is part of language, so definitely initial state should be the final state. When we read single A, it is acceptable. When we read single B, it should be acceptable. Right? Then if we read second A, okay, that is acceptable. 3A acceptable, 4A acceptable. So only A's are all valid strings, because they are starting with A and ending with A. Similarly, if we read only B's, then also that is valid. Now we have to adjust the arcs of B so that we can have a different combination of A and B's present. So from Q1, if we read first B, then it is not ending in A, because if we follow that path, from Q0 we are reading A. So string is starting with A, then it must end with A as well. So when we read the B from Q1, it should go to the non-final state Q2. But when we read, and we can keep reading number of B's and we will remain in non-final state Q2. To terminate, we must have to read A so that we are coming to the final state A. So this will ensure that whatever strings we are producing, they are definitely starting with A and ending with A. Now the same logic we will replicate from Q3, but now just different symbols we have to use. That Q0, Q3 path ensures that strings will start and end with B. When we read A, it is going to non-final state. From Q4, any number of A's we can read, we will remain in non-final state, and to go to the final state, we must have to read 1B. So this is what our L, that is string starts with end with same symbol. If we want to design DFA in which the strings having different start and end symbol. So if it is starting with A, it should end with B. If it is starting with B, then it should end with A. So that is the complement of the language. And for that, we simply have to do, we have to change the state of the states. If it is a final, we have to make it non-final. If it is a non-final, we have to make it final. Okay? So this is the DFA for the complement of the language. So L complement is nothing but a sigma star minus the L. So L is strings having same symbols on both the ends. So L dash is having the different symbols at both the ends. Complementation, a few more examples, like we already have derived even length DFA in earlier videos. So it looks like as shown on left hand side, and to generate the DFA for odd length, we are simply changing the final state. String starting with A, we have already discussed this DFA as well, and non starting with A will simply take the complement of that. Okay? So that are the valid DFA. All strings over alphabet 0, 1 that end with 111. So string must end with 111. Before that, there could be any combination of A and B. So a minimum length string is 111. It is accepted. Okay? Now we will try to adjust the arcs of 0. And we will ensure that it generates all valid strings. So from Q0, can we have arc of 0 on Q0? That is very much possible. We can read any number of zeros, but to terminate, it must end with 111. From Q1, can we have arc of 0 as a self loop? No, that's not possible. Otherwise, we can have a string 1, 0, 1, 1, which is accepted, and it is not ending in 111. So we have to now think back that now we have to add arc of 0 from Q1 to Q0. So once we read first one, and when we read 0, it will go back. To go to the final state, we must have to read consecutive 3, 1. Then only we are in final state. So that string is valid. From Q2 also, same reason. We cannot have arc of 0 as a self loop. We cannot have an arc of 0 from Q2 to Q1. It's only possible from Q2 to Q0. From Q4, arc of 0 is not possible as a self loop. Only possibility is that we go back to the Q0, and that ensures that to go to the final state, we must have to read 3A, 3, 1. From Q4, arc of 1 is remaining, and that we can add as a self loop, because 3A, 1 I have already read out. I can read any number of ones now. Okay, 3, 1 I have already read out. If I read 4A, 5A, 6A, or any number of ones, then it is ensured that string is definitely ending with at least 3, 1. Okay? 1, 1, 1. String will be ending with 1, 1, 1. So this is what our desired DFA is. All strings over 0, 1 that begin with triple V. So now 111 should be at the beginning. At the end, it could be any combination of 0 and 1. Right? So that is the desired DFA. All strings over 0, 1 that begin or end with 111. So if it can be either having 111 at the beginning or 111 at the end. So here, this is the DFA for 111 at the beginning. And now we will try to adjust 111 that will be at the end. So this will ensure that we have 111 at the end. When we read 0 from Q0, then definitely if string is starting with 111, then 0 cannot be the first symbol. So we are going from Q0 to Q4 because Q4 path ensures that string will definitely end with 1111, as we can see. Right? So now we will try to adjust arc of both the input symbols from all the states. From Q0, if we are moving to Q4, then it's sure that the string should end with 111, right? Because it is not beginning with 1, so it must end with 111. So from Q4, if we read 0, we can have a self loop of it, because even if we are reading any number of zeros from Q4, to go to the final state, we must have to read 31. Then only we can have string ending in 111. From Q1, if I read 0, then it should go to the Q4, because now string cannot start with 111. If we are following the upper half, then there must be 3 1 consecutively. Then there could be any combination. But after reading first one, if we are reading 0, it says that this string cannot start with 111 because it is having first symbol 1, second symbol 0. So we are going to Q4, and from Q4 it is ensured that that string will end with 111. So string should either start with 111 or end with 111. From Q2, if we read 0, the same reason, it has already read out 1, 1 and 0. So that string is not starting with 111. So we cannot go to the Q3. We must have to come on Q4, and Q4 will ensure that this string will definitely terminate in 111. From Q5, if we read 0, we'll go back to Q4 because that will ensure that 111 will be read out. From Q6 also, if we read 0, that will ensure that string is starting with 0, so it should definitely end with 0, 1, 1, 1, and that's what Q4 is doing. And same way from Q4, if we read 0, it is going to Q4. Okay? So this DFA will ensure that string would either end in 111 or it will begin with 111. If it begins with 111, then it will follow Q0, Q1, Q2 path. And if it is ending with 111, then it will follow Q0, Q4, Q5, Q6, Q7, that part. At any intermediate state, if we are reading inappropriate symbol, then it will come back to the Q4. All strings over 0, 1 that contains 1001 or 0110. So string should have 1001 as a part of it or 0110 as a part of it. So first we'll draw a DFA for 1001 or it is 0110. Now we will adjust all possible arcs of both the symbols for all the states. So from Q0, both arcs are already out. Before we add the arc, we will evaluate if it is possible to set as a self loop or not. If it is not, then we'll think for some other options. So from Q1, we can have self loop of 1. We can read any number of 1 from Q1, but to move to the final state, it has to read 0, 0, 1. So that will ensure that 1, 0, 0, 1 is present into the string. Similarly, from Q4, we can read any number of 0. This will ensure that to go to the final state, it must have to read 1, 1, 0 from Q4. So all the string generated through that path will have 0, 110 as a part of it. Fine. So Q0, Q1, Q4, we have all two transitions are out. From Q2, if we read 1, then it should go to the Q5. Because if I follow the path Q0 to Q1, it has read out 1. Then Q1 to Q2, it has read out 0. And now when we go to the final state Q7, then we have to read 1, 1, 0. Okay? So we are going to state Q5, Q6, Q7. So you see that in this string 0, 1, 1, 0 is present. And if 0, 1, 1, 0 is a substring, then we are following the lower half. And if 1001 is the string or is the substring, then we are following the upper half. So from Q2, if we read 1, then we have pattern 0 we already have read out. We are already reading 1. And for 1, 0, we already have DFA, Q5, Q6, Q7. So that arc we have to add from Q2 to Q5. And for similar reason, from Q5, if we read 0, it go to Q2. So we already have one readout either from Q2 to Q5 or Q4 to Q5. Then we are reading 0, so we are going to Q2. Then we will read one more 0. Then we are entering into Q3. And from Q3, we are reading 1, so we are going to Q7. It ensures that 1001 will be definitely part in any string which is following this path. From Q3, if we read 0, it is moving to Q4. So that will ensure that once we are in Q4, to go to the final state, we must have to read 110. We already have 0 read out previously from Q3 to Q4. So that's 0. Then Q4 to Q5, we have 1. Q5 to Q6, we have 1. And Q6 to Q7, we have 0. So it ensures that 0, 1, 1, 0 is sub part of string. And in same way, we can have a transition for input 1 from Q6 to Q1. That will ensure that 1001 will be the part of the string. And after reading 1001 or 000, it can have any combination of 1 and 0. So we can easily put the self loop of 0 and 1 on Q7. So from all states, we have already created 2 transitions. They all are generating valid transitions, and hence this is the final accepted DFA. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.